Alright, so hi everybody. This purpose of this video is to talk about some interpretations of our regression coefficients, as well as to introduce reading a table of output from some statistical software like R. And so before we really get going, I wanted to mention that our textbook does go through this process of calculating like the intercept and the slope by hand just through algebra. We're completely skipping these, and though our notes say that we're relying on R, we're only doing so indirectly because I'm relying on R to provide you with the tables, but you're responsible for knowing what everything in the table eventually will mean. And so our interpretation of regression of these coefficients, now we're kind of starting to get into the good stuff, in my book at least. We're going to start just by differentiating what our parameters are to what our point estimates are. That language should sound familiar from the other hypothesis tests and confidence intervals and data stuff that we've done. So just recall from kind of the very beginning of this that our regression model looked like this. And so our parameters in this model are just the intercept and the slope. And so we've got our beta 0, which is our true but unknown intercept. And we've got our beta 1, which is our true but unknown slope. In contrast to this, after we use our sample, we could find our best fitted slope and intercept from our data. And we're denoting those as a little b0, and that's going to be our estimate for the intercept from our sample. And we're also going to have an estimated slope, b1. So our estimate for the slope from our sample. This is super similar to how when we first started talking about hypothesis testing, we had a p for our unknown proportion, and then a p hat for something that came from our sample. Then we had like a mu for our unknown mean, and we had a mu hat or x bar for our sample mean. This is the same type of deal, except now there's two things. So we have beta naught and beta 1 as our unknown intercept and slope. And then we have b0 and b1, which are our estimates for those that come from our sample. And so the following kind of sets of tables give some typical output that you would see from fitting a regression model using statistical software. And so for now, I'm just going to make a note that we're going to ignore these three columns, and we're going to ignore these three. For now, we will eventually talk about almost everything in these two tables. For now, it's easy to kind of note that 463 is just the number of observations in our sample. And in this column that says estimate, this is where we're going to grab our fitted intercept and our fitted slope. And so you could probably guess that the row that says intercept is going to correspond to stuff about the intercept. It's slightly less obvious that the row that has our predictor, which was named beauty average, which we've been kind of calling attractiveness, this is going to have stuff for our slope. And so let's go ahead and write down what b0 and b1 are for this example. So b0 is 3.88. B1, our fitted slope, is 0.06664. And so our fitted equation, we could write out just like we did earlier. Would just look like that. And so let's go ahead and interpret this slope. And so the interpretation goes back to what we talked about, just what a slope means from like algebra, this like rise over run idea, but we're gonna put it in context of the problem. And so a slope in general is like how much we would expect y to increase or decrease for a 1 unit increase in x. And so for this example, our interpretation might be something like, okay, for a 1 point increase in attractiveness, so as x goes up by 1, what do we expect to happen to y? So we expect, on average, or we expect the average course score. What do we expect it to do? Well, that's where this fitted slope comes in. We expect it to increase. Since that slope is positive, then that means the line's going up, so we would expect an increase by 0.067 points. Let's also, just as we're getting used to this type of interpretation, just write down a kind of general template. And so in general, we're going to think about this as for a 1, whatever the units of x are, increase in whatever our x variable is, then what do we expect to happen to y on average? So we expect the average, whatever our response variable is, to either decrease or increase. So it's going to be a decrease if the slope is negative, increase if the slope is positive, and then by whatever our fitted slope is. All right, and so let's do the same type of deal for the intercept. And so you could take a break for a second. It's kind of a lot of writing. I still have my spindrift just like old times. So see, real squeezed fruit. That's it. Not like that polar garbage. So our intercept is going to be something like this. So we said that it was the value that we expect for y when x is 0. So I'm going to say, okay, when attractiveness is 0 points, what do we expect y to be? And so in this case, y is course score, so we expect the average course score to be 3.88 points, where I'm just grabbing 3.88 from this equation, or from here, or from here. In general, we might say something like, all right, when x is 0, and then whatever the units of x are, it's just what we expect the response to be. So we expect the average y to be whatever that fitted intercept is, and then we want to make note of what the units of y actually are. All right, so we'll pick up next time talking about extrapolation and talking about r squared as well. And if these interpretations are kind of rough at first, don't worry, you'll get some practice on the handout, and they will definitely get kind of easier with time.